okay, now we're going to use our annuity, our present value of an annuity formula, and we're going to rearrange it for n. So we're going to solve for n in the present value of the annuity formula, and then we're going to use this to answer a relevant question, right? So we're going to see when we might use this formula. So first thing we want to do is we have our present value of an annuity, is solve this equation for n. Note that n only shows up here, these are r's. So all we have to do is we want to get everything to the other side of the equation. And we know we're probably going to have to take a log here at some point to get the n down. So doing this, we can sit here and say, okay, well, the present value of the annuity, times r divided by c, that's moved that stuff over there, is equal to 1 minus 1 over 1 plus r to the n. And well, I can get this over the other side of the equation, so this should be, right, I move the 1 over, that's a negative. So this should be present value annuity, minus 1 is equal to that. Good. Nope, sorry. I'm trying to do this in my head, and it should be 1 minus that, pardon me. You can check my work. Now, the idea is I know I want to take the reciprocal at some point, so I can sit here and go, this is c divided by c, so this is going to give me c minus present value of the annuity times r divided by c, so now I can take the reciprocal, and this is going to be c divided by c minus pva times r is equal to 1 plus r to the n. Now all I want to do is take logs, right? So taking logs should give me my formula. The number of periods in an annuity is equal to natural log c divided by c minus pva times r over ln 1 plus r. Now, note here that anytime you do this, anyone can make algebra mistakes. So you want to make sure that the formula you've done makes sense, right? So the idea here is and this is going to be our example. We can start thinking about this formula in terms of our example. So the idea here is this is going to be the payment I'm making, and this is sort of what I owe. And if the payment I'm making gets lower and lower and lower, closer to what I owe, just a pure interest on what I owe, then this is going to get smaller, this is going to get larger, and it'll take longer and longer for me to pay this off. So this formula makes sense. So the idea is as c from above approaches the present value of annuity, this is going to get bigger. Note one thing here. Also looking at this, I know I have a log, right? You can't take the log of a negative number, so I know what we cannot have here. We have to have c is greater than PV, PVA times r, right? If this is not the case, if they were equal, this would be 0, can't divide by 0. So these two things cannot be equal. If we had the case of this was greater than c, then this would be negative, can't take the log of a negative, so it doesn't hold. So note that this only holds for this case. And as I'm going to show you, this makes economic sense. So you do want to kind of double check to make sure that the formula makes sense once you've derived it or once you've rearranged this. Good. Now, all right, so let's go to the example. So when can you use this? Well, a classic example of using this is calculating how long it's going to take you to pay off your credit card. So let's say you have a $10,000 credit card balance, meaning you owe $10,000 on your credit card. The APR, well, being generous here, and it's I guess a low APR, is 12% per year, which means 1% per month. You make monthly payments on your credit card. So given that your payments are going to be monthly, we need the monthly rate. Right? So $10,000 on our credit card, we pay 1% per month, right? So that's an interest on our that's the interest. We have to pay 1% in interest. Now let's say we choose to make a $150 payment each month, right? So from what we just talked about before, right, the present value of the annuity is going to be $10,000. 10,000 times 1%, 10,000 times R is going to be $100. So right now we know we have to at least make something more than $100. If we make a $100 payment, and the interest is growing at $100, this is going to be 0, and this is not defined. And what's the economic interpretation of that? You never pay off your credit card. So the idea here is if our payment is $100 or less, we never pay it off. And that's why N doesn't exist in those, because there's no number of periods, right? So we know that our payment has to be greater than $100. And intuitively, we can calculate this multiple times. The more it's above $100, right, the greater C is, the lower the number of periods that it's going to take. Okay. So let's plug in our numbers. So we have N is equal to natural log C 150 divided by 150 minus 100. So in other words, this is 10,000 times 0.01, right? Divided by ln 1.01. So before I started, I calculated this. This should be equal to 110.41 months. Months. That's bad handwriting for months. Good. So in other words, we owe 10,000. Credit card is 12% APR, which means we owe 1% per month. We make $150 payments. We should pay off our credit card in 110 months, right? So quite a long time, actually, when you think about it. So what you can do is recalculate this, increase this to 200, 300, and see the effect, right? What you could also do is start increasing this down towards 100. And as you get closer and closer to 100, the number of months is going to really increase, right? So again, at 100, you get nothing, right? You will never pay it off, which we used to call negative amortization, right? But as a term in the industry, when I worked in the industry, I didn't work for credit cards. I worked in other areas, but people, were allowed to make payments small enough such that they never paid off their balance, right? But while I was working, Congress outlawed that. As far as I know, I don't know if they've done anything since, but the idea here is, at $100 or less, you would be termed negatively amortized, meaning you never paid off. Excellent. All right, have a great day.